Okay, well, it's 7 o'clock. We'll get started. So, let me share my screen here. So, I mean, this is where we technically are on the schedule. This is week 6. This week you only had really one lesson, 3-7, and the next video called "Thinking God's Thoughts After Him," and then just an encouragement to get ready for the test, to take the practice test. So that's kind of what the original intent was. You can see at the bottom, I still have during week 6 the notebook and the test. But like I've told you, I've extended the final deadline to a week later. Okay, well, questions?
Okay, oh, sorry, go ahead, Kelsey.
Oh no, I didn't have one ready, really.
Okay. Can we do 34, 47? I think I just wanted to get the reasoning behind why it's a contradiction.
Can you tell me what section that's on?
Sure, it is 3.4, number 47.
Okay, so I've got it up on the screen here. Let me get it in the book. Let me get there in the book. 3-4. So it says, show by means of a truth table that statement is a contradiction. Okay, so first of all, what do we call a truth table that the answer column turns out to be all truths?
A tautology.
That's correct. And just the opposite happens when we get a truth table that results in all falses. We call that a contradiction. So I've got the truth table up here. I mean, it's all right. It's P if and only if, not P. The if and only if is another way to say a biconditional.
Okay.
So because there's only one letter, this truth table on the left here, I mean, that's the only two ways the statement P can be, true and false. And then not P is just the opposite, false, true. And then when you do an if and only if, what's the rules for that, the biconditional?
They have to be the same.
Yeah, true only when they're alike. That's correct. And you notice in both cases, they are not alike.
Oh.
So true is not like false, false is not like true. And so both results are false, and that illustrates that it's a contradiction.
Would I have to go backwards to do the false, true, true, false to figure out if it's the same answer?
I don't know. I don't know what you mean.
Well, I was wondering, it's true, false, that would be false. And then it's a false, true. Well, would that be? Oh, okay.
I'm not sure what you're referring. Okay, so in the first statement is true, and the second statement is false. They are not alike, therefore
they're false.
False. The second statement, the first is false, the second is true. So the result is they're not alike, false. That's the whole truth table.
Got it.
Because we only have one letter this time. I mean, P. We don't have a Q. By the way, do you guys remember what's the general rule for how many rows you need in a truth table?
2 for each letter, right?
That's correct.
Okay.
Well, two to the power of how many there are. So, for example, what if we had 3? What if we had P, Q, and R? How many rows would we need?
8.
That's correct. 2 to the 3rd power, 8. Very good. So anyway, on this one, we only have one letter, 2 to the 1 power, 2. Welcome, Rachel.
Thank you.
Nice to have you here.
Thank you. It's good to be here.
Right now, we're going through, somebody asked a question about 3.4, number 47.
Oh, okay.
Yeah, but yeah, I think we've talked about that one.
Yes, we have.
Is that what you wanted to know there, Leah?
Say again?
Does that answer your question?
Yes. Mhm.
Okay. The questions are pretty much wide open. Let's see, Rachel, we were looking at the week 6 schedule, which we're currently on.
Okay.
And you really only if you're on schedule, you really only had one lesson this week, 3.7.
Yes.
And there's the video you need to watch called Thinking God's Thoughts. And then, there's that one assignment, and then you're supposed to spend time working on that practice test for chapter 3.
Yes, and I'm partially done with that.
Awesome. So you can ask questions wherever it's kind of wide open. Okay.
Okay.
Anywhere you'd like.
Let me get my stuff together.
I actually have a question on number 9 for 3-5.
Okay.
I was just confused. I think on all of the ones that say no.
3.5, number 9, did you say?
Yep. Yeah, so number 9 and 15 too.
Got you.
They're similar.
Well, I've got 15 ready to go. Yeah.
Okay.
This is the Euler diagram assignment. And I know looks like there's circles everywhere here. So we'll just start this one over. Hopefully, let's see. Let me draw a line. How can we do this? Try to find a space off to the side. Okay. So first of all, this is 3.5, number 9. See, we got that slow cursor again. Okay. 3.5, number 9. Where are we? 3.5, number 9. All right. No drinkers are healthy. Yeah, you're right. This to me is like soap opera talk, and I'll explain. Have you noticed how I don't watch soap operas, but when I've viewed a couple, it's like whatever you do, don't tell the truth.
Yeah.
I don't know why if they say no drinkers are healthy, doesn't that mean all drinkers are not healthy?
You'd think so.
Yeah.
Well, that's the way I interpret that. So no drinkers are healthy. So what I'm going to do is make a circle for drinkers and a circle representing healthy. Do you think that drawing represents that first statement? No drinkers are healthy?
Yep.
Okay, good. Now, no joggers drink. Now, this one's a little trickier. Where are we going to draw the jogger circle?
See, I wanted to draw one just like anywhere, like not connected to any of them.
You can. This. I'm going to call this jogger 1.
Okay.
But isn't it also possible joggers could look like that?
Yep.
Because no joggers drink. Well, they don't drink here either. In fact, couldn't it even look like this?
Yep.
So you got to kind of keep all 3 possibilities in mind now when they go to the conclusion. What's the conclusion?
That it's invalid?
No joggers are healthy. That would be true if we were down in this J1 circle. But it's not true if we're here or if we're here. Because it's not always true,
It's invalid. Okay.
that's an invalid. So that's how you're supposed to use these Euler diagrams. But you need to expand and think of all the ways that, you know, like I did here. There's three ways that could appear. Let's do 10 too while you asked about it.
Oh no, I asked about 15.
Oh, okay. I'm sorry. 15.
No, that's okay.
Yeah, this is kind of funny. Okay. No math teacher is wealthy. All right. So this is number 15 on 3.5. So no math teachers are wealthy. So here we have math teachers. Here we have wealthy. Okay, so far so good?
Yep.
No Panthers teach mathematics. So it's almost like we did before. Change colors here. So that we could call that Panther 1. Right? No Panthers. Panthers don't cross over the math teachers at all? Yes?
Yep.
Here's Panthers 2. Here again, no crossover with the math teachers. Oh wait, let me try that one again. And couldn't we even have okay. So there's three possibilities. Now, what's the conclusion? No Panthers are wealthy.
That it would be invalid.
Yeah, because of P2 and P3.
Okay.
So this is almost a repeat, isn't it? Yeah. Do other two ladies pick up on that?
Yes.
I'm getting like a feedback. Hopefully you aren't. I'm hearing myself talk back to me, but that's okay. As long as you guys are hearing me clearly, we're good.
Yes.
Yes.
All right, good. All right, so I think those are the. Was there another one you asked about?
And then 35.
Okay, 35 on that same assignment.
Yep.
So what are the directions here? Use an Euler diagram to determine which conclusion is true. Oh, okay. So this time they're having us pick a conclusion. Okay. So $35. Okay. Some math problems are difficult. So if I draw a circle for math problems, a circle for difficult, some of them are in the difficult circle. Second one, all difficult problems need attention. Okay? So where do I draw needs attention?
Around.
I gotta surround the D.
Yep.
So let's call that needs attention 1. But isn't it possible this could also happen?
Yep.
Okay, and I think those are the only two possible ways that could be related. Now, which conclusion shall we pick?
Some math
Some
problems.
math problems need attention.
Yep, it could be that one, or
How about the other one? Some math
Um,
problems are not difficult.
no. So it would only be A, right?
Wait a minute. What's wrong with that second one?
Some math problems are not difficult.
Yeah. What about like right in here?
Oh, I guess so. That's right.
So looks to me like both of those
So
would,
both of them.
would
Okay.
could be used. Yeah, either one. From what I can see, it should be either one. Yep.
Okay.
Anyone can go next.
Can we go over 3.6, number 29?
Yes. Yeah, I'm gonna have to do it over again because these diagrams get kind of messy.
Okay.
Okay, so let me get some new space here. 3.5, number 29.
Yes. Finding the valid conclusions using all the premises.
Okay. So, no doctors are enthusiastic.
What, 3.6, 29 is all politicians.
I'm 3.5, yep.
Okay, no problem.
Oh, this is 3.6, so I have this
Yeah,
written
3.6.
Okay, 3.6, number 29. I'm getting there.
Oh, you're fine.
Oh, yeah, so no people, all right, so all politicians run for office. So in other words, if you're a politician,
You
then
run for office.
does this make sense if I write it like that?
Yes,
If you're a politician, then you run. Okay.
right.
Now, second one, no people who run for office are reliable. Isn't that another way of saying if you run for office, then you're unreliable?
Yeah, so that'd be the not for the R? Or no?
If you run for, we got another.
Yeah.
If you run for office, then you are not reliable. I'll use RE.
Sure.
Okay, so here's our problem. Now, so you, this is Rachel, I think. Is that your voice?
Yes, sorry. Yes, it is.
So, do you remember, Rachel, or did you see in the videos, did we ever do any chain reaction problems?
I think so.
Yeah. So anyway, if you have P, then you get R. Oh, and if you have R, then you get not RE. So if you have P, you're going to wind up with not RE because these two chain together.
Okay, yeah.
So the conclusion is if P, now let's just translate that. That says if you're a politician, then you are not reliable. How true. I'm sorry.
How true.
I should keep political statements out of this, but
Oh, it's fine.
it seems to me to be very accurate.
Me too. And that makes sense. Yeah, I remember the chain reaction one.
Yeah, this becomes a chain reaction problem.
Okay. Thank you.
You are welcome. Rachel, I think you told me your, what was it, your Thursday class ended now?
No, we're just on break for the holiday. I forgot about that. So
Oh, okay.
I'm jumping in here.
Anyway, it's nice to have you on board tonight.
Thanks. I wish I could do it every Thursday.
Yeah, I know. I guess we're all doing too much. I don't know. You guys, I know you guys are very busy. Any other assignment questions we should take a look at?
I have one on 3-7, numbers 17 and 19.
All right. So, yeah, by the way, it's kind of odd. What you notice they use that little apostrophe, number 17, that's P, what, complement?
Yep.
That's actually like a negation sign. So, and because the not P and Q are a straight line from each other, that's an and. So,
Okay.
here's my interpretation of that right here. Okay, parentheses, not P and Q. Okay, now that is what? That is above, not Q and P. And when you have something above, that's an or situation. So that's why I put an or here. And then what's on the bottom rung? Not Q, whoops, not Q and P. So do you see where I got this thing from?
Yep. Yep.
All right, cool. Now, of course, that's not the whole thing. Now that is side by side with a not Q. Therefore, it's anded with not Q.
Right.
All right.
I guess I just didn't realize that you had to do the truth table for those.
Well, if you're going to simplify it, here's what you have to see. Okay, so if we take that original, take that argument, all right, I've got P, Q, so I really need 4 rows because I have 2 letters, P and Q. So I set up a 4-row truth table with P and Q. I threw in a not Q because I thought that'd be helpful. And then I did the truth tables, and here, this column right here, that column right there has the result of that left section, and it's FTTF. Okay? Now, when you look at that, I got to think here now. Hang on a minute. And then we got to and it with not Q. Here's the final answer of the whole thing. FTFF. Okay? Is there anywhere else in the truth table that you see an FTFF? Do you see it's right here?
Yep.
And what's that represent? Oh, that's just not Q ended with P. So in other words, that whole network could just be a P next to a not Q.
Okay.
So this big old long hairy thing up here is exactly the same as doing this. Now, let me tell you why that's a big deal. See, these people, when you're designing electronics, which one, I mean, if you were going to make a circuit for this and a circuit for the one on the bottom, which one do you think would be more efficient?
Oh, the one on the bottom for sure.
Absolutely. And they're paying big bucks to find people who will simplify networks, because think about it. It makes it cheaper, you have less parts, and it makes it quicker.
Right.
I mean, that's the whole electronic industry. You want to be as quick. So anyway, quick and cheap, everybody's happy, the customer. So anyway, that's simplifying a network. Now, if you can't find anything in the truth table that has that same signature, then you have to use this section called basic conjunctions. I have to find it for you. This may not ever happen, but I'm looking. Basic conjunction, where are you? I'm going to have to find that. I know it's in there. I just can't picture exactly what page it's on.
That's okay.
Basic conjunctions. It's backwards, though. I do know that. I think I even have a slide on it someplace. Well, I'm sorry, I can't find it at the moment. I will find it though, and I'll get that to you. But anyway, so usually if you just look around, you'll see, oh, I got a column with that same exact, that pattern. And if you just look above, oh, a much simpler name, and you have just greatly simplified your network. Yeah. Now, what did you say? It's 19 too?
Yes.
Yeah. Oh, there. Here's the basic conjunctions. Now I found it. Look, it's on page 127. I even have the page there. Yeah, it's that table in number 49 on page 127. Anyway, let me just go through it again. So this time, what are we doing with this problem? Number
just simplifying it.
Yeah, where are we here? We're on 37, number 19. Okay, so first of all, we have a P or Q because the P and Q are above each other. Do you see that?
Yep.
So that's this part. Okay, and then that's stacked. So again, it's an OR with another stack of Q or P. So pen got a little overreactive there. So you've got a PQ stack, and that's stacked with a QP stack. So that's this set of brackets here on the left. But then we're still not done. That then is ANDed with a not Q. So here's the whole, this red bar represents the whole truth table that we need to evaluate. All right, I evaluated all of that, and I got FTFF. Okay, now you notice there is no FTFF. If you look back on this one, there is no other column that has that. So you go to your basic conjunctions. All this is taking P and Q and not P and not Q, and ending them, ORing them, all the different combinations. You notice This one is it. FTFF, P and not Q. So simplified network. Oh, is that the same answer we just did? Just by accident?
Yep.
That's
Yeah, I
weird.
think so.
That is weird. 17 and 19 come out the same, but notice the problems were different. No, they weren't. They were actually identical. 17 and 19 are the same problem?
Huh.
Oh yeah. Yep.
Oh, no. No, this was an and problem. They're not the same problem. This was and, or together. 19, we've got or and or together. So even though the answer came out the same, it's not the same problem.
Oh, okay.
So do you see how on this one, I could find no other column that had the same signature as that.
Right.
So then I had to try the basic conjunction. It's just trying P, Q, ending, and not Q and not P, ending and oring them.
Okay.
So anyway, that's a little bit over the top, but that's how 19. That's how 19. And you guys get the side by side is the and the stack is the or, right?
Yep.
Okay.
Yes.
Wow. Good questions. Time just like flies by.
Oh yeah.
Holy cow! I can't believe how. Okay. Good questions. Any what's next? In a few minutes, I want to, even though we're going to have another week where we can do this, I'd like to spend some time going through the practice test problems. Rachel might have a question or two on the practice test.
Yes, I did do some work, and the rules of the truth table I'm still trying to finish memorizing.
Gotcha.
So I had a little bit difficulty there, but
Yeah, you're right. That you've got to really nail those rules in your head, and then it goes much more smoothly. Yeah. You got T's and F's flying by, and you got if then biconditional. Oh, you got all these different. Yeah, you got to know. I think it's basically 5 rules you got to know. Yeah. Okay, and only
So what
true
I did-
both are true, or
right.
only false if both are false. If then, only false when the first is true and the second is false. And then the biconditional, only true when they're alike. Oh, and then I missed one. The one that's not in the book. The exclusive or.
Oh, yeah.
Only true when they're different. Yeah. So anyway, there's the rules. Yeah. Assignment questions? Anybody else?
I did mark that I needed to review from the practice test number 7.
Okay.
Because I think I got the not P correct. And yeah, the not P was correct, but everything else I chose was wrong.
Okay. Well, basically, this goes back to those rules, Rachel.
Right. That makes sense.
Yeah. So I wrote in the answers. Sorry, it's kind of blurry. But
No, I got it. I can see.
so you got your base table on the left there, P and Q.
Right.
And like you said, you already got A. B. The only one that's true is when both of them are true. That's a perfect example of your and.
Okay.
So B goes.
With the P and Q.
Yeah, exactly.
Okay.
Okay. On C,
That's the negation.
P is the opposite of P. Instead of TTFF, FFTT. Yep.
Yep.
D only false. Oh, here's the if then, because it's only false when the first is true and the second is false.
Okay.
So that's this one right here. That's this, that's the if P then Q one.
Okay.
And then the last one is what? Only false when they're both false. Which one is that? That's the or. That's the
yeah, the P or Q. Mm-hmm.
So that's your E over here.
Okay.
So you're right. This is really a basic rules question. Yeah.
So that's my problem.
Well, that'll be.
I'll work on those.
But you'll have to get that.
Mm-hmm.
Now, the only the difference is, see, when I give this in class, they can't use their notes.
Right, right.
You, of course, are not prevented from using your notes when you take a test. However, you're going to be scrambling like a mad creature looking for help, and that's not going to work either. So you really do need to have them. You got to have them down pretty good. Yeah.
I did rewrite them just again on paper together so that I could rewrite them and read them.
What I do in class, I've had people look in the door and think I was nuts because I make these symbols with my hands,
Yeah, I heard you talking about them.
Yeah, and but each day you need some kind of a repetitive, go through it, get them memorized. Yeah. Yep.
Okay. Then I should be fine.
I think you will. So, Leah, Kelsey, have you gotten to the test yet?
I have not yet.
Okay.
I've gotten to it.
Just wondering if you do have any questions on that. Those would probably that's probably what we'll wind up doing next Thursday night. But but if you want to take your test starting this Friday night, well, then we probably should deal with that stuff right now.
And what again is the deadline for that?
Yeah, Rachel. Okay, here we changed it. So if you go back to the, here's the schedule for this week.
Right.
And at the end of it, I still have notebook 3.
Okay.
If you look at well, you can't see everything here, but if you look at you click on it. So
okay.
You can hand it in. You can hand it in as of this weekend already.
Sure.
But it's not due until next weekend.
Okay. Awesome.
And then when you go back to the test, if I can get back there, when you click on the test, yeah, it's actually, you could take that as early as 5 o'clock tomorrow.
Okay.
But again, it's not this has a deadline on it, but the deadline, it says will close Sunday the 15th. So you have an extra week basically on the notebook and the test for this chapter.
Then I might be able to memorize those.
So you do have some time to memorize. Yep.
Awesome.
Can we, maybe this is going ahead, can we do maybe practice test 3, number 14, going over the converse, inverse, and contrapositive? For some reason, I still get those mixed up.
I'd be happy to.
Thanks.
So that's kind of a weird question, number 14, but because it's just kind of awkward English.
Mm-hmm.
I don't think any golfer talks about making a score of 62. But anyway, you're supposed to take this. If you make a golf score of 62 once, you will make it again.
Mm-hmm.
All right. So the if part is you make a golf score of 62 once. The then part is, even though there's no then, does everybody see it's implied?
Yes.
Yes.
Yeah, then you will make it again. All right, so for so here, yeah, I used the symbols. So the first one might be called, the way the statement is originally, it's like if O, then A. If O for once, then A again. Okay. So there's the original statement. B says, oh, A is the converse. So the converse is, if A, then O. You just literally reverse it. And when you're doing the inverse, you what? You leave them in the same order, you just negate them. So it was if then A, it's if not O, then not A. And then the contrapositive, you have to flip them around and negate them both. So if O, then A, if not A, then not O.
Got it.
Again, you put that into a sentence, it gets really awkward. If you didn't make a golf score of 62 again, then you didn't make a golf score of 62 once. But anyway, with symbols, it's a lot. I think I'm trying to show it more simply.
Okay, thanks.
Yes. Did you say another one also in the practice test?
Not yet.
Okay. I just.
Can we do a 17 on that practice test?
Yes.
Thanks.
Yeah. Thank you for asking about this one. Because this always gives people grief. Okay, what is an implication? If you don't know what an implication is, you're never going to get this problem. Okay. An implication is an if-then statement that results in a tautology. So in other words, it's an if-then, and all the answers are true all the way down.
Okay.
So notice we just have three basic statements with a table. We have that ABC table in the top left. Okay. So now what we've got to do is try if-thening all of these things. So we could do if A, then B, if A, then C, if B, then C. So we got to try all the combinations. And then once you got those written down, 1, 2, 3, 4, there's 6 different combinations. Now you got to test out their value. So if A, then B. If true, then true, true. If true, then false, false. Why did I quit? Because that can't be a tautology. So looks lazy, but hey, I mean, it can't be. All right, then try if A, then C. If true, then true. If true, then true. If false, then false. They're all good so far. If true, then false. Fails on the last one. So anyway, you just run through and you notice 3 of them that I've starred came out to be tautologies.
Okay.
If B, then C. If B, then A. And if C, then A. So then you write the special symbol B arrow, equal sign arrow. That's called B implies C. B implies A. C implies A. So so an implication is an if-then statement that results in a tautology.
That makes sense.
by the way I figured out those 6 ways you could rewrite it, I just said, all right, let's start with A. If A, then B. If A, then C. All right, start with B. If
B then C.
B, then C. B, then A. I mean, those are the only 2. Okay, C. If C, then A. If C, then B. I mean, we've got all the combinations now, and then just test them out.
Okay. Can we do 310, chapter 3, practice test 10?
Number 10.
Yep.
Yep.
Okay.
So sorry for the marks on there, but basically the question is, which of the following statements is equivalent to not P or Q? And they give you 2 choices.
Okay.
Well, the way I would find out is I'd do the truth tables. And if the truth tables come out the same, then they're equivalent. So here's the first statement, not P or, well, yeah, here's the one they gave you, not P or Q. And then not P and not Q. And B is, you know, what do you, I'm trying to remember the name. So do you remember De Morgan's law?
Yes.
So what's De Morgan's law for that blue circled B one? If you negate something and with an and in it, it's negate both statements. So P negated is not P. Not Q negated is Q. And you got to reverse the connector. Notice instead of and, it becomes or.
Yes.
Okay, so now, so here's the original right here on the left. Here are the other 2. And then I didn't follow through. Let's just do it right now. Okay, let's finish the truth table. So not P and not Q. Well, I don't have all the nots, but all right. Let's see if we can do this. Not P and not Q. False and true. Only true and both are true. True and false. True and true. So is that one like the original?
No.
No.
No, not. So it's probably going to be B, but let's just check it out. Not. Oh, yeah. I mean, we did De Morgan's law. Look.
Yeah, that's on 112, page 112.
Look, it's even the same symbols. So that's it. That's our guy.
Okay.
I didn't even. Yeah. I was going to say do the truth table. We could do that, but wow, we even have the same name. So that one really is checking if you know De Morgan's law.
Okay.
By the way, when you guys are getting your notebooks ready this time,
Yes.
if don't forget to look back at the comments that I wrote to you last time. You know, there weren't many, but I wrote comments to you on, you know, maybe one thing was a little bit lacking or whatever, or maybe I was all praise. I don't know, but sometimes what happens is that students don't look back at what I gave them last time. They make the same mistakes again, and that's not a disaster. It's just, why would you want to make the same mistake again when you can so maybe just go back and look at that comment. Yeah, I forgot. Was it Leah? Was it you that sent me? You weren't able to upload yours.
No, I wasn't able to.
Yeah.
I sent it via email.
So in your case, I sent you something from in email. Yeah.
Okay.
Whereas the others, if you go look online, I think your comment is right online with where you handed it in. Yeah.
So will this test be over just chapter 3 then, or what page? Just chapter 3 then?
Yeah, similar to the topics in the practice test.
Okay.
The chapter 3 practice test. Yeah.
Got it. So it's not comprehensive.
Only 3.
Okay.
Of course, there is crossover. You know, like De Morgan's Law we learned in chapter 2, and it came up again in chapter 3. But I mean, it'll only be questions on chapter 3.
Okay.
Interesting. I hear you guys paging through your notebooks.
Yeah.
That's what I'd be doing too. Yeah.
Do you think that we could go through 3-2, number 41?
Yep.
Okay.
Okay. So let P be Maida is a blonde and Q be Maida is 6 feet tall. So under which conditions is it true? Well, under which conditions is the statement Maida is blonde and 6 feet tall? So basically, A is asking you P and Q. You see that?
Yes.
And what is the rule for and?
Oh, that they both have to be true.
Bingo.
Okay.
So really, this is a way of checking your rules. Let's just
Gotcha. Okay.
under which conditions is the statement Maida is blonde and 6 feet tall false?
P or Q?
Well, what they're saying is when is P and Q false?
When one is true or the other?
Well,
Is
when
false.
they're not both true, right?
Right.
Right. When one is true, one is false.
Or they could both be false.
Right. Oh, yeah. Sorry.
So I think the best way to say it is maybe to say it not both true.
Okay.
So do you want me to keep going?
Nope. I think that makes sense now.
Okay. Well, we're at the hour mark. Still looking. Anybody have another want to bring up?
I think I'm good.
I'm
right
good.
now.
Me too.
So we'll have two before you have to have this test done. We will have 2 more get-togethers. The Monday office hours, virtual office hours, where we do that chat, and then next Thursday we'll do this again.
Okay.
All right.
All right.
Thank you.
Thank you.
Thank you.
Welcome.
Bye.
Good night, ladies.
Bye.
Night.
Bye.